Yes, it's true. We will be making a robot out of popsicle sticks and hot glue. Funny enough, I've learned this is the best way to prototype. You can sit there and 3D print 1,000 different models, but if you're designing your own 3D prints every time, it's going to take some time. It's going to cost money, waiting for them to print. It's just, I think popsicle sticks are a really quick way to prototype. So yeah, we're gonna do this. You know, as an electrical engineer, I want to do robotics. At least it interests me. And so I've started thinking, how can I get into robotics? How do I start? My program at college doesn't really cover it at all. I mean, a little bit with Arduino, but hardly. And so I wanted something that was challenging, but also doable for someone at my skill level. And, well, I thought about doing the Hexbot. Hexbot should be pretty cool. It's, should be doable. It's definitely a stretch challenge, but should be doable. Here we go. So I actually started this project a while ago, but while moving back home, I kind of destroyed it. It got wrecked in the travel. So I'm spending this first part putting it back together, lining up the legs, lining up the servos, making sure the angles are angles are all right. And this is pretty important because pretty much when I start coding them to go in different directions and stuff, they need to be accurate to what they're supposed to be. If they're off by even a little bit, you know, it's going to mess up the whole process, the whole walking process. So this is pretty important, trying to make sure I can get it as lined up as possible, considering I'm using popsicle sticks and hot glue. The problem is I kind of put them all on in the wrong order. So now what I need to start doing is testing each one and finding out which motor is lined up with which number in the program. So as you can see, I'm spending this time writing down manually with a Sharpie on each part what number they align with. A couple things to think about is how it's going to walk, right? It's got 6 legs. There's a couple different variations you can do. Oh, I'm in nature. There's weird noises. Anyways, so I decided to do a pattern. I don't know what it's called, but I'll show you later what it looks like. But pretty much you got 2 legs on one side moving with the middle leg on the other side moving at the same time, and then vice versa. So we've got 2 little tripods moving, alternating sequences. And I'm going to be setting angle restrictions on the servos too, and that's going to help them pretty much not collide with each other and chocar. So that's pretty important. So yeah, here we go. Well, now it's time for a walking test. Woo! So as you can see here, it's a little fast, but the legs are not moving the way they're supposed to. Yeah, basically they're all kind of moving in their own random way. The elbow joints are actually all moving how they're supposed to. They're pushing back while they're down, and then they lift up and move forward. But yeah, all the hips were wrong. So after reprogramming all of those, putting them in different configurations, I do believe we figured it out. It's working. It is working. This is a good step. It's working. Is it perfect? No, but it's working. That's what matters. Look at that. We got them all moving how they're supposed to. Lovely. So even though it's working, it's a little quick and hasty and robot-like. How ironic. I'm gonna slow it down. Make it slower, smoother. Here we go. So this is much better. They're moving slower, and I need that for, well, my lightweight design of the frame. So that's, wow, look at that. Fantastic. Well, now it's time for the first walking test. This is a big step, guys. This is a huge step. Walking time. All right, here we go. Walking test number 1. As you can see, it is kind of walking, but it's not really like moving a whole lot. Looks like it's really struggling. Well, I will see it was exciting to see it, but look at my face. I'm not impressed. Not impressed. So I started to think about, what can I do to make it walk better? So that first test was a little sad. I mean, it's still progress, but it was a little sad. I was kind of expecting more, not sure why. The popsicle sticks were just kind of too slidey and didn't have enough traction, so it kind of just like sat there and was like, you know, not very useful for anything. So we're gonna put on little sticky, like semi-sticky little pads, hot glue those on. They add a lot more traction, maybe too much, we'll see. All right, as I set up for a walk test part 2, here we go with the new sticky feet. As you can see, it is getting a lot more like ability to push forward and actually walk, but it's also like losing its legs. I think the problem here that I was getting is, well, it's good for pushing forward because it's kind of half sticky, but it also adds more drag, which became a big problem. So, and it hit the scissors right there, yeah. So, yeah, I mean, it's better than the first one, but still not what we need. All right, so that's gonna be pretty much the end of our testing for today. But honestly, even though the results weren't exactly as cool as I wanted them to be, this is huge progress, huge. We went from 6 servos in my first model to now 12 servo motors in this model. I call it Mark II. And yeah, we're pretty much hitting a wall here where I'm gonna have to just upgrade some of the parts. For one, we're gonna switch to 18 servos to add 3 points of movement on each leg. It's gonna allow for the legs to actually lift up and not drag as much. So hopefully that'll help. Because of that, I'll need more power too. So the next video is gonna go over installing more servos, a crazy increase in power, especially dealing with current spikes. Servos have huge current spikes. So we're gonna need a huge battery. We're gonna need buck converters. There's a lot we're gonna go over in the next video. So this is more of an intro. The next video is gonna be super hands-on, probably longer. Maybe it'll be multiple parts. We're also gonna 3D print a frame. Yeah, it's time to upgrade from popsicle sticks to 3D print. So yeah, that's it. Thank you for watching. If you made it this far, I kind of doubt anyone did, but if you made it this far, congratulations. You are a premium viewer. So I appreciate the view. Yeah, stay tuned for more. And let me know what other type of videos you guys want to see. Anything from engineering to travel to literally anything. Goodbye.